go ahead and just let me show you that. So this is what the book, I think it is already there in that drive. You can just access this, try to download it. And this is the DO280 book. It's a Red Hat OpenShift administration operating a production Kubernetes cluster. So as I told in the demonstrations, guys, this OpenShift has been built on the top of the Kubernetes. Like Red Hat people, they have taken the basic source code of Kubernetes and they have added some extra features and they build this OpenShift environment for us to deploy our applications. Okay. So that's the reason they have named like this way Red Hat OpenShift administration 2 operating productions on Kubernetes clusters. Okay. So there are, I guess I have shown you there are 7 to 8 chapters that we have. If I will show you, yeah, these all are the chapters that we're going to cover in our sessions. The first topic is describing the Red Hat OpenShift control platform. So regarding our OpenShift product, how this OpenShift can be used in the production environment, what all are the features they have added on the top of the Kubernetes clusters that we're going to discuss on today. And also, as you know, for RSCSA, RSC you already have done, we do have some lab environment which has been given from the Red Hat. In the same way, in the DO280 OpenShift, also we are getting this labs where we can practice our guided exercises and all. Okay. So we will be going through all the chapters in the book itself. So whenever I will be taking the sessions, meanwhile, I will be showing you the books one by one. We will go ahead and I will be telling you about all the chapters that we have. One for 6 chapters. So 7 chapters we do have in the theoretical chapter it is, and first chapter is also in the theoretical chapter. So coming to the next, we do have this managing clusters with web consoles, the chapter number 8. It's another chapter we are also going to cover, but chapter number 9, it's just a comprehensive review that what are the things we have covered till chapter number 8, we will be discussing in the chapter number 9. So it's just a gist of that, of whole topics that we have covered. Now, coming to the first topic that we have, introduction to this DO280, Red Hat OpenShift Administration 2, operating production Kubernetes on Kubernetes cluster. So first of all, we will be trying to understand about our the environment, how this lab has been built for us, and we will be trying to discuss about that. Just give me a moment, I'm just coming back. Yeah, sorry for the difficulties. Okay, fine. So where are we? Okay. So we will be trying to first understand about our environment, what kind of lab they have given. As you know, guys, in RHCC you already have done. You do have two servers, server A and server B, and there was some workstation server. And in RHC, if you have done, then there was some server A, server B, server C, and server D. And also there is one orchestration where it's working as a control node in the Ansible, right? In the same way, we have given different servers in our DO280 in the OpenShift. So the first machine I'm talking about, this workstation machine. This workstation is having both GUI and CLI mode. That is my graphical user interface and command line interface. You already have aware of this workstation machine, guys, that you will have to log into this workstation machine and you have to do everything in the OpenShift clusters. Okay. So now workstation is the only machine you will have to log in. And there you will have to deploy your applications, whatever the things you are going to practice, everything you should have to do by logging to this workstation machine. Okay. Now coming to the next, we do have a Bastion server. It was there in our RHCS and RHC as well. So this Bastion server, it is just acting as a bridge, which is helping to this workstation machine connect to the classroom machines. Okay. It's just working as a bridge. Okay, and it's working as a bridge which is connecting this workstation machine to the classroom machine to help to get the network. That means this Bastion, once it has been connected with the classroom, the workstation machine is going to get the network. By getting the network, you can see by network means it is getting the internet. Okay, if you want to pull any source code, they can pull it from the GitHub. You know, guys, GitHub, it's a repository where we do have the codes. Okay, developer used to write their code and they're pushed to this GitHub. Okay, it will store all the codes. And QA.io, it is just kind of registry that we have previously used our Docker Hub. In such kind, we do have this QA.io is another, it's kind of hub where we do have the where we do have this images and all. Okay, and we are also having another hub, the Docker Hub, where we're calling it as a Docker Hub. In Red Hat, where we do have this registry.redhat.io. It's another hub or another registry where we do have all the images available. And to get this images and all, we should have an internet in our system. So to get this internet, we are having this Bastion, which is acting as a bridge, which is trying to connect from the workstation machine to classroom machine to get the internet. Now, if I want any source code in the workstation, I can just I log into the GitHub, I will pull it. But without any internet, it can be possible. So that has been taken by this Bastion. So Bastion is taking care of this workstation, how this workstation machine is going to get the network or the internet. Okay, so that it can able to pull the image, it can able to get all the required ports, everything they can get it. Without any internet, they won't be able to get that. So this is what the Bastion machine is going to help us as a bridge, which is connecting from the workstation to classroom machines. Fine. Now coming to another machines that we have a utility in our RHCS also. You have done the container questions. This utility machine was also there. So this utility machine is acting as a storage server, which is predefined NFS. Like NFS has already been installed because you know, guys, NFS storage that you are going to mount it for a particular ports. We will be discussing about that. I don't want to make you confused for now. So just try to understand this utility is a server that it's just acting as a storage server for here. So here some of the storage class we do have, and this NFS has been pre-installed in this utility. And for this, okay, let me just write it. NFS has been pre-installed inside this utility, and we will have to create a mount, or we have to build a volume, and that volume we have to share to the OpenShift clusters. Okay, as previously in our previous class we have seen, guys, from my base machine I have created one volume, and that volume I have attached to a container. In the same way, in OpenShift we do have a different concept. We have a different chapter for that also, how exactly OpenShift is going to get these storages and all. But in container, yesterday I have shown you how exactly this container we can attach to the volume in the container from the host machine. But in OpenShift, we do have a different concept. We do have a different chapter. In chapter number 2, we will be trying to learn about that. But just try to remember this one. This utility is nothing but it's acting as a storage server where this NFS has been pre-installed. We will have to export this NFS volume to our OpenShift clusters. So here you could see there is another servers we do have master 1, master 01, master 02, and master 03, where the initial pre-installed OpenShift cluster. So these all the three machines, this OpenShift cluster has been installed, guys. Okay, if we will talk about the real-time scenario, guys, how exactly there will be. So in your real-time scenario, there will be multi-master concept. Okay, let me just talk about your in Ansible what we have. In Ansible, there was one control node to control our managed nodes. We do have a control node there, right? Suppose I do have 3 managed nodes. So there is a control node. These all are the managed nodes we do have, right? Who can control this all total managed nodes? In Ansible, we have learned. In OpenShift, in our real-time scenario, we do have this multi-master concept. So multi-master concept means what? There will be multi-master nodes. Suppose this is M1, M2, M3, and this is M4. Okay, multi-master nodes. And we are going to deploy our applications on the worker nodes like this way. Depending upon your application load, you will have to create number of work nodes. Okay, worker nodes we are calling it. So now this master can able to handle this particular worker nodes. Okay, so we do have multi-master nodes M1, M2, M3, M4, and we do have multi-worker nodes here. So usually we will be going to deploy our applications inside the worker node, not inside the master node. So master will help us to connect to the worker node, and we will be deploying our worker node by log into this masters. Okay, I will be telling you how exactly we are going to log into the masters to deploy the applications on the worker nodes. Usually, guys, the applications will be deployed in the worker nodes. These all are the worker nodes where the applications will be deployed. And you must have, before using the OpenShift, you will have to install the OpenShift cluster in these machines. That means OpenShift should be available in each of the machines so that the OpenShift cluster can be made. So now, here in my scenario in our lab, instead of creating multiple machines M1, M2, M3, so if I will do separate master and worker node, I do have suppose 3 machines I will be using, then I should have to use 6 as a master and the worker node. But instead of creating multiple machines in our environment, what they did is they created this master node which is also working as a worker node. They created this master 2 node which is also working as a worker node, and they created this master 03. It is also working as a worker node. But in real-time environment, you do have separate worker node, you do have separate master node. From the master node you will log in, you will deploy the application on the worker nodes. But here in our scenario, this master node is it's also working as a worker node. This master 02 node, it is also working as a worker node. This master 3 also, it is also working as a worker node. They don't have create multiple machines to deploy the applications. They will be using the same master and the same worker node here. Is it clear? Any questions? Vishali, any questions from your end? Are you good? Did you understand where the application is going to be deployed? Am I audible?
Yeah. Yes, yes.
Okay. So this is what the lab environment the Red Hat people has given. So we do have 1 workstation, bastion, 3 utility, and 3 nodes. That means 6 nodes we do have, and one another is classroom. So 1, 2, 3, 4, 7 nodes we will have. If I will show you that, let me just show you that one. Yeah, you could see here. Bastion server, 3, 6, and 7 servers. You could see this. So workstation machine, I will always have to log in. And from this machine, I will log into the master nodes. And as I told you, this master, they're also using as a worker node where the application is going to be deployed. Okay. I told you in the real-time scenario, in real time, we do have multi-masters and multi-worker nodes. The pods or the applications will be deployed inside this worker nodes, not in the master node. So master node is going to handle those worker nodes here. Okay, so we will be trying to log into the master nodes. I will tell you how exactly we are trying to log in, not directly. We will be trying to see by using the API servers. We will be trying to log into the master nodes. From the master node, we will be deploying the application to the worker nodes. Okay, so fine. So when I will be telling about the architecture of the OpenShift and architecture of the Kubernetes, on that time I will be telling you how exactly it can be differentiated. Okay, how exactly we will be logging to this master node and how we can log into this how we can deploy the application into the worker nodes then. Okay. And one another thing, you will not be able to do the SSS to any of the masters. From the workstation machine, if you want to do the SSH, you will not be able to do that. From the workstation to master 2, master 3, you will not be able to do the SSS to any of the nodes. Okay, the master nodes, you will not be able to do the SSH. Then how exactly we will be able to log into the masters? We have a separate topic for that. We will be using a module called debug module, which will help us to log into the master node, and there we can see what all are the informations about the masters. But if you will do SSH, you will not be able to do the SSS to this master nodes. But in real time, you will be able to do the SSS to each of the master nodes. But here they have created in the different network. If I will show you what all are the IP address of these machines, you can see the workstation is having 172.25.250.9, which is having both graphical workstation, graphical and command line interface. And there is one classroom, bastion, utility. And you could see here, master node is having some different IP address, which is in different range. So you will not be able to do SSS to this master nodes. Okay. And how exactly we will be logged into these masters, I will tell you in the class, in our chapter number 2 or chapter number 1, I guess. Second chapter, we will be discussing about that. Okay. So this is what the servers and this is what the lab environment we do have. So there are 7 servers we do have, and you already have familiar with this login and all. So if you want to open this workstation machine, there is one option called open console. So if you just open the console of workstation, then it will open another tab in our browser where we could see the login page. And here, if you want to log in for the student, there is a password called student. We'll just go ahead and log in through the student name. And if you want to open the terminal, there is one option called activities. By clicking on this, there is one option called terminal. There we can, okay, this is what my terminal is. So from here, I will be trying to log into the API server, which will help us to connect to our master nodes. I will be telling you that. Okay. So what is this API server? How it is helping us to connect to the master's nodes? So we will be discussing about that. So this is what the scenario that we have learned about our lab environment. Okay. Fine. So let's try to understand about the OpenShift, how this OpenShift is going to be work, what is OpenShift, and what OpenShift can be done. Okay. So let's try to understand about that. 1 second. Okay. Let's come to the first chapter that we have. So describing the Red Hat OpenShift container platform, we are calling it as a RHOCP. Red Hat RHOCP, we are calling it as Red Hat OpenShift Container Platform. Okay. As I told you, oh, sorry, I so much. Yeah, Red Hat OpenShift Container Platform. So what is this OpenShift? Do you know, guys, what is this OpenShift? What the OpenShift can be done? It's an orchestration tool. Okay. In the first demo sessions, I told you, right? It is going to manage our containers where the application has been running, right? So I told you in the previous sessions in our demo sessions, right? If I do have a different types of nodes, and in different types of nodes, I do have some pods which has been running. Suppose there are 3 nodes, I have pods are running. If this pod wants to talk with this pod, it can be able to do that because they both are in a different network. And if this one pod wants to talk with this pod, it can be possible because this both the servers are in different network. So to overcome such kind of drawbacks, we have coming with a new layer called Kubernetes, and this Kubernetes is going to be help us for the communication between these pods and all, right? We have discussed about that. Not only that, we do have a container which has been running inside this particular pod that is going to be managed by the Kubernetes also. Suppose somehow, if I will trying to discuss about this OpenShift, so you should have the knowledge about Kubernetes also. Like you don't have to worry about the Kubernetes concept. What is the Kubernetes? What is the command we are going to use? But you should have to at least know what is Kubernetes is. Okay. Let me just tell you here. I think we already have discussed about that. Okay, let me try to discuss again. See, if I do have a three different type of nodes, I told you master one, suppose this is my worker one, worker two, and worker three, because I know that my application is going to be deployed in my worker node. Suppose this is my worker one, worker two, or you can say in my environment, if I will tell you as the master node, I'm going to use it as a worker node, I can just use as M1 also. So I'm just giving it as a worker one, worker two, and worker three. And if I'm going to deploy applications, I do have to create a Kubernetes layer on the top of that, right? Kubernetes layer. And on the top of the Kubernetes layer, we are calling it as a pod. Instead of container, we are calling it as a pod. And suppose there are two pods in the worker node one, and there are one pod is the worker node two, and there is another pod in the worker node three. If this pod wants to talk to this pod, they won't be able to do that, because the worker one and worker two is in different network, and worker three is also in different network. So this Kubernetes is going to be managed how this pod can talk to this pod and how this pod can talk to this pod, right? And not only that, as you know, guys, the pods are ephemeral. Yesterday I told you the containers are ephemeral, that can be deleted at any time. If there will be an issue with the particular container, or there will be an issue with any pods, the pod can be destroyed or the pod can be died. So this Kubernetes is going to be taking the responsibility. If the pod is going to be died, it will recreate one another pods on the top of this worker nodes. Wherever this, not only in the worker node one it will create, it can also create in the worker node two as well. There is one another concept, but just remember this one. This Kubernetes is going to take the responsibility that if the pod is going to be died, it will recreate one another pod on the top of that, so that the end user who is going to be access to this particular applications, they won't see any data loss, or they won't see any access kind of error. If they won't see that, because if the pod is going to be deleted, the Kubernetes is taking the responsibility. It is going to create this another pod. Ultimately, guys, in later run sessions, we will see how this end user is going to be access to our applications, through which it is going to be access to our applications. But ultimately, let me tell you, this user is going to access to this particular pod because this pod is containing the container, and the container is holding our applications. That means whenever the traffic is coming from the user to the container, how this traffic is coming to this particular container, we will be trying to discuss. Because container is holding so here you can say pod is holding the applications, but usually pod is nothing but multiple containers will be there inside this particular pods. So ultimately, this container will be holding this particular applications. In Kubernetes or in OpenShift, we are calling it as a pod. Okay. Now inside the pod, so when the user is going to be hit to the application, ultimately the traffic will come inside the container, and inside the pod we can say, okay, inside the pod, how this access is going to be happened. Okay, we will be discussing on the next chapter that we have. So just for now, try to understand, to remember this one. Kubernetes is a base. On the top of that, Red Hat people have built their OpenShift, and OpenShift, it is an orchestration tool who is going to manage our applications, which has been deployed in the pods. Okay, which is deployed in our pods. Fine. So this is what the OpenShift is, guys. So let's come to the book now. So describing the Red Hat OpenShift container platform. So here in the first chapter, it is totally depend on the theory, and we will be trying to understand about the product, what all are the features the Red Hat people have added inside this OpenShift. Okay. So first, we will be trying to learn about the Red Hat OpenShift container platform. We already have discussed about that. Provides an enterprise-ready Kubernetes environment for building, deploying, and managing the container-based applications. I told you guys, this OpenShift is going to be handled or deployed or managing our container-based application. So what all are the application has been deployed in our containers or in our pods, this OpenShift is going to be handled that. Not only that, it is helping us to build, it is helping us to deploy, it is helping us to manage our applications. Okay. And this OpenShift can not only deploy, or this OpenShift platform can not only deploy in the public data center, it can also be deployed on the private data center, including the bare metal servers also. They have mentioned here. In any public private data centers, including the bare metal servers, you can use this your OpenShift, Red Hat OpenShift container platform, RHOCP. So if you do have any public data center, if you do have any private data centers, or if you have your bare metal servers, I told you in the first I have shown you how exactly we are going to install the CentOS machine, and on the CentOS machine we have installed the Docker, right? So in the bare metal server also you will be able to install this Red Hat OpenShift cluster. That doesn't mean like you do have such kind of subscription you have to take. There only you will be getting this RHOCP, but no. So it's so free. You can also use it in your bare metal clusters or bare metal servers. Okay. So it is compatible. RHOCP, the Red Hat OpenShift Container Platform, is compatible with multiple cloud or virtual providers also. So we do have multiple cloud environment like your AWS, GCP, and your Azure. So wherever you want, you can also deploy these OpenShift clusters as. So this is what the product Red Hat OpenShift Container Platform. So OpenShift can be deployed in any environment. Either it can be in private or public cloud, or it can be in private or public data center, or it can be in the bare metal servers as well. Okay. So that doesn't, so if there will be a questions where it can be deployed, it can be where it can be built. I'm sorry, just a minute. Okay, where it can be deployed or where it can be built in any servers, in any bare metal servers, you can be able to build this one. Okay, fine. So coming to the next point that we have. Give me a moment. Fine. Coming to the next point, Red Hat OpenShift dedicated. I just have discussed you guys that whenever you can also use this Red Hat OpenShift container platform. Okay. Red Hat OpenShift container platform, not only in the bare metal or the data center, you can also use in the cloud-based option that we have called GCP, or it can be Microsoft Azure, it can be IBM Cloud, or it can be the Amazon Web Services, the AWS also. Okay, so this can be also used in this. This Red Hat OpenShift can also use this in the cloud platform as well. Okay, and coming to the next point that we have Red Hat OpenShift Online. So actually for this Red Hat OpenShift Online, they have given a new features to the customers now. Like if you want to deploy your applications in the containerization, you are going to deploy the containerization applications by using this Red Hat OpenShift. You don't have to worry about the infrastructure. You don't have to worry about the migration or the patching, whatever the things been happened to the service. You don't have to worry about that. You just have to talk to the Red Hat people. They will be giving the infrastructure. They will be giving you all the related things which is been required for the application deployment in the containerization application deployment. So they will be giving you the environment. They will be giving everything. You just have to deploy the application, and whatever the cost you have to pay to the Red Hat people, you have to do that. Okay. So and however, this Azure or AWS is being given to us to create our own environment to deploy the applications, right? In the same way, the Red Hat people is also are giving this particular this option they're also going to give us, that we can deploy our applications in any environment, but we don't have to worry about the infrastructure because Red Hat people is going to be taken care of that. And even you don't have to worry about the migrations also. And you are also not worry about the patching activities on that particular OpenShift clusters. Okay, so this will be handled by the OpenShift, the Red Hat people. And coming to the next point that we have Red Hat OpenShift Kubernetes engine. I already have discussed, guys, how this Red Hat OpenShift has been built. The first one is what you should have a proper machine. On that particular machines, we will have to install the Docker, right? Because the container, the pod is holding this particular container where the application is going to be deployed. So this Docker, we are calling it as a here as a CRIO, container runtime. Okay, container runtime interfaces that we have. So this is the prerequisites of this OpenShift. That means whenever you are going to deploy your OpenShift environment or OpenShift cluster, you should have this Docker pre-installed in your server. Not only Docker, guys, it can be any container runtime environment. It can be Docker, it can be Podman, it can be Rocket. These all are the applications we are using for the containerizations. So we are calling it as a CRIO. It's nothing but the container runtime. So container runtime is modes. It's just the containerized applications that we are using for. It can be Docker, it can be Podman, it can be Rocket also. And on the top of that, we are just trying to install our Kubernetes, right? I told you in the first dev session, sorry. Kubernetes. On the top of the Kubernetes, we are installing this OpenShift, right? Because Red Hat people, what they have done by taking the source code of this Kubernetes, they have built their own environment as OpenShift by adding some extra features also. Okay, so this is how the OpenShift has been built. First OS, then container runtime, then Kubernetes, then on the top of the Kubernetes, we do have OpenShift. So this is what they have explained here, guys. You can see. So now provides the subset of the features present in the OpenShift control platform, such as the Red Hat Enterprise Core OS lightweight transactional operating system. So instead of using this the RHL, the Red Hat Linux, they're coming with a new OS called as Red Hat Enterprises Core OS, guys. It's another operating system which has been given from the Red Hat, and they are trying to use this on the OpenShift environment. Okay, because this Core OS is such kind of lightweight transactional operating system. It is having some minimal packages, and it is very lightweight also. On the top of that, they will be trying to install our OpenShift environment. And transaction, so they have told us the Cryo engine, the Kubernetes container orchestration platform. On the top of that, we are installing this Cryo. On the top of that, we are installing this Kubernetes orchestrations platform. Okay, then only we can able to build our OpenShift environment there. And coming to the next things that we have, Red Hat code ready containers. So what is this code ready containers, guys? Instead, if you are using this particular OpenShift platform, you can also use this code ready container. It is known as CRC. If you are having a less number of resources, you can use as movement as it's just kind of beta version, I can say. So you can use this code ready containers here. So that means suppose one developer wants to deploy the applications in the productions, but before that they just wanted to do the testing. So how can they do this testing on their codes? They can install this code ready container on their bare metal server in our local machine in the VM that I built. On that particular build, on that particular VM, I can just go ahead and install this Red Hat code ready containers, and I can just use that for my testing of the codes or for the testing of this applications and all. Once it has been tested, you can just use that same code in the production environment. So many developers, they are going to use this particular Red Hat code ready containers. Okay, we do have a different packages we do have for that code ready containers. We can just install in our VM and we can do the setup on that. Okay, so this is what the Red Hat code ready containers. Now let's try to understand what all are the features is being given from this Red Hat people on this Red Hat OpenShift. Okay, so as I told, Red Hat OpenShift can be built in any environment. It can be physical, it can be virtual, it can be private cloud, it can be public cloud. In any environment, you can build this Red Hat OpenShift container platform. Okay, so on the top of that, we will have to install some OS. That is what my Linux I'm using. Also, you can use this Core OS. Okay, this is a lightweight transactional operating systems. So Core OS also you can use it. And on the top of that, I told you already, container runtime or packaging. It can be Docker, it can be Podman, it can be anything. It's just we are calling it as a Cryo, right? Container runtime interfaces. So now on the top of that, we are going to install our Kubernetes. This Kubernetes is nothing but the container orchestration or container cluster management, right? This is nothing but our Kubernetes. And if you're going to build this environment, you should have its own networking. It's having some own storage. It's having own registry. It is having this logs and metrics to track what all are the things has been happening to my cluster. And it is also having the security. As in, so each we do have a different topic, guys. The networking, OpenShift networking we have, storage we do have, registry. It is just a, previously we have seen whenever we are trying to build a container, we do have an image. So that image we have found in the Docker Hub. But in Red Hat, we do have an internal registry for the Red Hat, which is a QA.io, where we do have all the images available for the OpenShift environment. And this Red Hat OpenShift is going to be used, the internal registry view, which is going to be help us to deploy the applications. Because whenever we are going to deploy the applications, you should have to build a container. And how the container has been built? By using the image. So first, we will have to pull the image, we'll have to build the container, we will have to deploy the applications. So to build the image, where we can find the image, this we are going to find it in the registry. And log and metrics, how exactly we are going to get all the logs in my environment. If I want to check the log of my OS, already in the Linux, in var log we do have. But in OpenShift environment, how could we get the logs of a pod? How could we get the logs of a master nodes? How could we get the logs of my clusters? That we are also going to get it by using this logs and matrices. We do have a different topic for that. And coming to the next, security, it is going to give you more secure, because as you know, this OpenShift is going to be used in the many companies who are having some more number of transactions, like your banking domain, your airline domains. They are going to use it because they cannot use this Kubernetes, guys, because Kubernetes is the community based, it is the open source one. That's the reason this banking domains or banking companies are using this particular Red Hat OpenShift on their environment. Okay, so this is what I just told you about that. So now coming to the next, what all are the extra features they have given on in OpenShift. Now you can see here it has been written as application lifecycle management, that is my CI/CD. Okay, let me just give you an example. Suppose I have a developer who is going to deploy his applications, and after deploying the applications, he wants to change their codes. Suppose I have a user on the first day, I have written some codes. After that, I deployed. Now, after some days, I want to change my codes. Again, if I will be changing my codes, again, I will go and deploy. No. So at that moment, we will be able to use this particular CI/CD pipeline style. So CI/CD, continuous integration and continuous deployment. So if a developer is going to be used this particular OpenShift environment, they don't have to worry about this any code changes. If he is doing, they don't have to again come to the terminal and again they don't have to deploy his applications. They can just integrate these applications into the CI/CD, so that whenever they are making any changes in the code, automatically it will accept the codes and it will run in the environment. Okay, and by making the CI/CD, we can build, we can automate our build and we can automate our deployment here. Okay, because I told you, right, if next day the developer is going to change his code, he doesn't have to worry about that again he has to come to the terminal to redeploy the applications. No, they can just reintegrate, or they can just integrate this application in the CI/CD, so that whenever there is any changes in the codes, it will by default accept and it will run in the environment. So this is how we can automate our build, we can automate our deployment here. Okay, and coming to the next one, service catalog. In the service catalog is nothing but, guys, we do have a beautiful console which has been given from the Red Hat. That means, so in GUI format, we can also do the deployments, we can do the managing services, everything in the web console. That means what? If a developer doesn't have any Linux command idea, so what they can do is they can just log into this web consoles and they can deploy the applications by using the GUI method. So whatever the things we will be trying to launch here in the CLI command line in OpenShift, we do have this web console through which we can do the same thing in the GUI method also, graphical user interface. If you have remembered in the RHCSA, guys, I have told you there is one service called Cockpit, through which I can just log into the server in the GUI mode, and there we can do what are the things we have done in the command line, we can do the same thing in the GUI also. That means in the OpenShift, what I'm trying to say is, if you want to deploy the application, either you want to deploy by CLI or else you can do in the GUI also. But doing this GUI, it is very simple. Just log into the console and try to do whatever the things you want to do there. Okay, it's very simple one. We do have a separate topic for that. In chapter number 8, we are going to discuss that how we are going to deploy the applications, or we are going to manage the services by using the web consoles. Instead of commands, we can also use this web consoles on the times. And about this self-services, the self-service means what? Suppose I am a user, I am a developer, I want to deploy my applications. Nowadays, if you do have if you are not using this OpenShift platform, now if a developer wants to deploy his applications on a VM, he will be telling to the administrator, hey administrator, I need a VM, just give me a VM. And after getting the VM, the developer is going to deploy his applications. If you're not using the containerized or you are not using any OpenShift platform, still if you are using any VMs kind of things or physical machine or virtual machines. So administration will take 1 or 2 days. He will be doing the post building of this particular VM. He will be going to do the post build activities on the particular VMs. After that, he will be handed over this particular VM to the developer. Now developer will log into the server and he will be deploy the applications. But if you're using this OpenShift, you don't have to worry about the creating any VMs or what. Now the developer directly they can log into the consoles. We will have to share the consoles informations like your credentials to the developer. Now the developer will go ahead and they will log into the web consoles. By using this web console, you can directly deploy his applications. That means here the developer doesn't need any administrator to build a VM for him to deploy his applications. Okay, so this is what the meaning of the self-services is. Okay, so this is what they have explained it here. If just give a time and try to read it out. I already have uploaded this book in your drive. Okay, and here they just have tried to differentiate between the Kubernetes engine and the OpenShift. Now after building the Kubernetes engine, what all are the extra features the Red Hat people have built that they are trying to make you understand here. So as I told, it can be built in any environment. It can be physical, virtual, public cloud, private cloud, or managed cloud like your Azure, AWS, or IBM, Red Hat. These are the clouds also we can able to install our Red Hat OpenShift. So now on the top of that, we just have installed this Red Hat OS. Either it is in RHEL or it can be Core OS. And on the top of that container runtime, my Docker or whatever I just have told you. Then on the top of that Kubernetes that installed, and the cluster services, the networking, the router, we already have discussed about this, right? The cluster services like your registry, networking, log and matrices, these all are the things will be there in this particular Kubernetes engine. But on the top of this Kubernetes engine, what all are the extra features they have added on the OpenShift, they have described it here. So we already have discussed. The first one is the CI/CD, that if you want to deploy or if you want to integrate your application on the CI/CD, you can do it. And if you want to use any build cloud native applications, which is required any kind of communication in the backend with the DB, or with any integrations is required for that particular applications, it can be done by the Red Hat OpenShift container platform also. And the developer productivity, as I have told you, if a developer needs deploy applications, he doesn't need any administrator to build a VM to deploy his applications. He can just go ahead and deploy his application by using the web console. So there will be a productivity from the developer as well from here. So these are the extra features which has been given on the Red Hat, on the Kubernetes engine by the Red Hat people. Okay, these are the features which has been given. So don't worry for this. We will be going deeply once we will be starting the topics that we have. Okay, fine. So hope it is clear. Any questions till this? Okay, fine then. So let's try to understand about this high availability that we already have discussed. In your real-time environment, there won't be having some of the worker node. They will be having a huge number of worker nodes. So I do have master nodes who is going to be handle this particular workers. So I do have this worker nodes here, right? So I told you already. So according to your application load means what you guys can understand. How many people are, it's depend on your customers. If you have a less number of customers, then you the application traffic, the traffic will be less. If you are having a more number of customers, the traffic will be more to the applications. That is what I'm telling you guys, the application load. That means, and not only for that, and what applications the resources can be taken also, that depends also. Suppose I am going to go for a deploy one Java application. So Java minimum it's required this much of source resources, this much of RAM, this much of storage it's required. So according to your resources, according to your application load, you will have to create this worker nodes on that time. Okay, and this master node is going to be handle this particular workers, and we will have the multi-master nodes. Why? Because if this master node is going to die, and the services will not stop. because we do have another two masters who is going to handle this particular worker nodes. Okay, so that the user will not lose the data, or user will not get any other issues with that particular applications. Okay, that is why we are coming with a multi-master concept here. Okay, if one master is going to be down, then another two masters can handle this worker nodes. Okay, so this is what the high availability, guys. Okay, and the lightweight operating system, I already have told you about the core OS that we are using. It's a lightweight transactional operating system which is being used to deploy our OpenShift container platform. Okay, and coming about load balancings, we do have a different topic for that. Load balancing, there are three types of load balancing we have. One is here, the cluster provides three types of load balancers. One is external load balancers, which is going to be managed to our OpenShift API. We will be trying to discuss about this API. Another load balancers, we do have HA proxy load balancers for the external access to the applications. If I will tell you now, guys, let me tell you here. I told you the application is going to be deployed on the pods, right? Suppose I do have 4 pods on this moment. This is my pod 1, pod 2, pod 3, and pod 4. In all the pods, my applications are running. Okay. Now there is one user who is going to hit to this application. I do have multiple customers who is going to hit to this particular applications, right? Now, in every organizations, we do have this kind of load balancers, guys. So what this load balancers will do, it will give the load equally to each of the pods. That means when this first user is going to be hit to these applications, this load balancers will redirect the traffic to the first pod. Now the first portion or the first customer has get the data. In the same way, when the second user will hit to this particular application, to the load balancer, this load balancer will redirect this particular traffic to the second pod. And again, in the same way, it is going to manage the traffic in the pods. Like in this particular manner, this load balancer is going to be handle our traffic. Suppose again another persons will come, then load balancer will get the traffic, and again he will first check. It is calling it as a round robin format, guys. So this load balancers, once it will get this traffic, it will first again it will see and share the traffic to the first pod. So now, if I do have a 4 pods, the first traffic will be get by this particular first pod. Again, when the 5th traffic will come, this first pod will take care. Got it? So this load balancers is going to handle, or it is going to give the equal load to the pods. Okay, this is how. So this is what the HA proxy is going to be handled. Okay, the HA proxy load balancers for the external access to the applications, I just have told you. And there is one other internal load balancers who is going to use this net filter roles for the internal access to the application pod. Suppose I do have a front-end pod and I do have a back-end pod. And in this moment, this front-end pod wants to talk to this particular back-end pod. Suppose this is my DB pod and I do have some another application which has been running in the front-end. And there is one particular load balancers. This is how also load balancer can be worked internally in our clusters. Okay. So this is known as the internal load balancers. So there are 3 types of load balancers. Don't worry, guys. This is I'm just telling you in the theoretical things, but we do have a separate topic for that where we will be doing in lab environment in the lab as well. So there are 3 types of load balance. I just have told you load balancers. One is external, another is HA proxy, and another is internal. Okay, we will have a topic for that. And automating scaling, I just have told you guys, if the Kubernetes in this, yeah, here it is. So automatic scaling means what? This Kubernetes, as I told you, it is handling this particular pod status. That means when the pod is going to be died, it is recreating one another pod. Okay, it is automatic, guys. We don't have to give any information to Kubernetes that, hey, Kubernetes, just go and create the pods. The Kubernetes will automatically create these pods. So that is, they have mentioned here in automatic scaling. Okay, and logging monitoring, we do have a topic where we will be trying to understand about the cluster logs, how exactly we are getting the logs at the cluster, not only the clusters. As I told you guys, we do have OS. On the top of OS, we do have what? The Docker, the container runtime. On the top of that, Kubernetes, we are calling it as a kubelet. Okay. On the top of that, we do have this worker nodes and all, right? Or the OpenShift container platform. The way we are calling it as a worker node, suppose worker one, right? Worker node has been built like this way, guys. First OS, on the top of this OS, we have the Docker. On the top of the Docker, we have kubelet, the Kubernetes. Then the OpenShift means the worker node has been built. So we can get the logs in each of the parameters. If you want to get the logs in the OS, you can get it. If you want to get the logs from the Docker level, you can get it. You can get the logs from the kubelet level, the Kubernetes level, and you can get the logs from the OpenShift level as well. So if there is any issue with the particular worker node, if you have particular pods, you can troubleshoot that particular applications, that particular environment or worker nodes by using this particular logging and monitoring options that we have in the OpenShift. Okay, so we do have a different topic where we will be trying to discuss. In next topic only, we will be trying to discuss how exactly we are going to get the logs. Okay, then services discovery. Here they are using this RHOCP runs an internal DNS service on the cluster and configure all the containers to use that internal DNS. So they are using this internal DNS, guys. You are already aware of this DNS, domain name server or domain name service, you can say. So where it is instead of using some IP address, they are also using some naming convention. By default, whenever the pod will be deployed, the pod will be having some particular IP, right? But this pod is also having one name also. Okay, and how this name is being given by using this particular DNS operator that we have, we will be discussing that. We do have an operator who is going to give this particular DNS name, the naming convention. It is going to handle the naming of this particular pods. So instead of putting the pod IP address, we can also use the pod name as well. So they're just using this particular internal DNS service to do that. And storage in container, I told you guys how we are going to attach the volume from the physical machine, from the base machine to the containers. In OpenShift, we do have a different concept. We have a separate server for the storage where the NFS has been pre-installed. We will be using that particular storage and we will be export to the clusters by using any volumes. Okay, the storage, we have a topic on the third chapter. We will be discussing that. Then this is what the application management. So we can also use the we can also use this applications. We can also deploy the applications by using the source code images. Suppose if I want to deploy my Nginx applications, I will have to build this application by using the Nginx image, which has been there in my internal registry. We are calling it as a source to images. We will be trying to discuss about that as well, that how the application can be deployed by using the container image, the source code images. Okay, by using the Git. Suppose I am a developer, I want to deploy one applications. I have written some code and I will be using some particular Nginx image. How exactly I will be deploying that? We will be trying to also learn that. So there is a command called OC new app, which will help us to deploy our applications by using the codes and by using this particular image. Code is going to be deployed and image where the container, it will help us to build a container. And once the container has been built, the code will deploy and the application will be deployed on the top of that. Okay, this is what the application management. So we can deploy the Python, Ruby, Java applications on the top of this OpenShift clusters. And the cluster extensibility, RHOPC relies on standard extension mechanism from the Kubernetes, such as extension APIs and custom resources definition, add features that otherwise not provided with the upstream Kubernetes. OpenShift packages this extension are operators for ease of the installation, updates, and management. So how this OpenShift is going to be taking care of this updates, installation, and management. In chapter number 7, we do have a topic where we will be trying to understand about this cluster extensibilities. Okay, so yeah, these all are the features has been given in our OpenShift, and we do have OpenShift architecture also that we will be trying to understand in the next week, in the next class, how this OpenShift is going to be worked. And on that time, I will also show you the OpenShift, the Kubernetes architecture as well. So because by knowing the Kubernetes architecture, you will be easily understand the OpenShift architecture there, because it is working samely as the Kubernetes. Okay, in the left hand side, you could see here the Kubernetes. This is what the Kubernetes architectures or Kubernetes engine architecture, they have tried to explain it here. It is in the control plane they have tried to explain, but I will be showing you in the architecture wise on the next day sessions. Fine. So that's it for today. On next day session, we will be trying to learn about some new extra things, the features, the architecture of the OpenShift. And after that, we will be trying to jump to our second topic, and we will be trying to discuss our health of the clusters, how exactly we are managing our clusters, or how we are going to get the logs of each parameters. So how could we troubleshoot it? We will be trying to learn in chapter number 2. Fine. So that's it for today. If you have any questions, please let me know. I already have added this drive, the Docker drive in that OpenShift